Good morning children and welcome to online teaching session. And this is continuation of organic chemistry from basic principles and techniques chapter. So in this, today I am going to teach homolysis followed by substrate and reagent. Number 2, nucleophiles and electrophiles. If time permits, I will continue with the topic that is types of organic reactions. Fine. In the last class, I taught heterolysis. Homolysis comes immediately after heterolysis. Homo means similar. Lysis means cleavage or breaking. Right? So, homolysis means an organic reaction with reference to organic chemistry chapter, wherein a bond which is binding two atoms or groups of atoms is cleaved in such a way that the bond pair of electrons is equally divided. Means here bond pair of electrons means 2 electrons. Out of 2 electrons, each electron will go with one atom or group of atoms of the molecule. Right? So, that electron pair is equally shared or divided. So, such a reaction is known as homolytic reaction or homolysis. Now, let us see this in detail. So, first one is homolysis. So in this reaction, we are going to take a molecule, and in that molecule, how the electron pair is equally divided. That is shown. Best example for this is ethane molecule, wherein 2 methyl groups we have in ethane molecule. Right? 2 methyl groups will pull that electron pair equally. Right? So electron pair will lie exactly between 2 carbon atoms of ethane molecule. But in presence of energy, what happens is this electron pair is equally divided. Let me give one example. CH3 X. What is that X? I'll explain it later. So remember, this is the bond which is binding X and CH3. And this can also be shown in this way. CH3, one bond means one electron pair. Right? Now, we are going to give small amount of energy, H nu. In structure of atom, this was taught. E is equal to H nu. E refers to energy, means H nu is particular amount of energy. So, in presence of that energy, what happens is this bond undergoes cleavage or breaking. As a result, we will get CH3, wherein carbon is carrying one electron with it. That electron we can show just above carbon and below carbon also, or just beside the carbon, plus X. Here both are possessing one electron each. Such species which are formed when bond is equally divided. Homo means similar. Another meaning is equal. Leads to the formation of the species carrying one electron each. They are known as free radicals. Free radicals. And here X can be another methyl group, right? So it can be written like this. If X is equal to CH3 group, if X is equal to CH3 group, then this equation can be written in this way: CH3, CH3. See, two methyl groups are there, and bond is lying between them. That is covalent bond, and that bond is formed by sharing of one electron pair. So, if we want, we can show this bond, or from understanding point of view, in place of that single bond, we can show single pair of electrons between two methyl groups. So this is one methyl group, this is other methyl group, wherein we have electron pair. Right? Since both methyl groups are pulling electron pair equally in opposite direction, so it lies exactly between the two carbon atoms. If small amount of energy is given, right, then the electron pair undergoes cleavage or breaking. As a result, we will get these species. Here, this X is nothing but methyl group. Now, these two are known as methyl free radicals. So, methyl free radicals are highly reactive species in chemical reactions. Once again, homo means similar or equal, lysis means breaking. So it is nothing but an organic reaction wherein bond is equally cleaved. In this case, an organic reaction wherein bond is equally cleaved or broken, and each fragment will carry one electron with it. So bond is equally cleaved. We got fragments or species, and each species is carrying one electron. Therefore, these are known as free radicals. Always free radicals possess one electron with them. That is why they are said to be highly reactive. Next, stability. Here one methyl group has one electron with it, right? So methyl free radical is this. There can be ethyl free radical, isopropyl free radical, right? So in that way, when we go on add one CH2 group, we will get a new alkyl group with solitary electron, single electron, right? As far as stability is concerned, methyl free radical is less stable than ethyl free radical. Ethyl free radical is less stable than CH3, CH3, 1, 2, 3. One more bond is not there. One isopropyl group. Right. Next, in that way, you can go for other alkyl group which has one more methyl group in it. That is CH3, CH3, CH3. Means as the methyl group's number increases gradually, stability changes. This is methyl free radical, ethyl free radical, isopropyl free radical, tertiary butyl free radical. So this is methyl free radical and this is ethyl free radical. This is isopropyl free radical and this is tertiary butyl free radical. Tertiary butyl free radical. So that's about the stability, how it varies each time when we add one methyl group. Fine. So that's about homolysis. And here the important point, one more point is there. That is, the reactions wherein free radicals are involved. What should such type of reactions called as? They are known as non-polar reactions. See, there is no polarity. Formed with free radicals do not have any charges. So they are known as non-polar reactions or free radical reactions. So that's about homolysis. Yes, children. Now we are moving towards another concept, that is substrate and reagent. So what is meant by substrate? What is meant by reagent? Imagine a molecule, right? It can be a hydrocarbon. From that molecule, if atom or atoms are going to form new bonds, then that substance is said to be substrate. The other substance which has participated in that reaction with that hydrocarbon part is known as a reagent. This is the concept. So we can write like this: a substance wherein its atom or atoms involved in the formation of new bonds is called, it can be new bond or new bonds, is called substrate. And the other substance is known as reagent. That is about the concept. Okay. So any substance wherein the atom or atoms involved in the formation of new bonds, that is called substrate. Now I am going to take one example so that it can be clear to you. Now look at this reaction wherein ethene molecule has taken part in chemical reaction with other molecule, and that molecule can be bromine. It can be hydrogen bromide also. Okay. Now here bromine we can write Br2 or Br single bond Br. Why I have written this in this way is I want to show combination of each bromine atom with one carbon atom of ethene, thereby to form new bond between carbon and Br. Right? Now what happens is one Br join with one carbon. Means this carbon is going to form new bond with bromine. Similarly, other Br will join with carbon atom, other carbon atom of same molecule. Right? As a result, we will get CH2 here, Br. Other CH2 is there, that is called methane group, which has very short life. CH2 alone cannot exist because of its very short life. But there are two CH2 groups, that is ethene. That is different. Okay. Now, other methane particle, and with that we are going to join Br. This carbon is forming new bond with this Br. At the same time, this carbon is forming new bond with this Br. Therefore, this CH2 single bond CH2 is substrate. Means this one. So this substance is substrate, and Br2 is reagent. Very simple. carbon atoms of ethane molecule. There are two carbon atoms which have formed new bonds with Br on either sides. Therefore, this part is substrate. This part is nothing but the first reacting species, that is ethane, substrate. The other one is reagent. Okay. Now, I'll move to example 2. Here I have little space, so let me write here. Example 2. And here I am taking benzene molecule and this I am treating with methyl bromide. Now, where combination or formation of new bond is going to take place, there we can show one bond attached to hydrogen atom. Anyway, out of 6 corners of benzene. Now, what happens is this hydrogen atom will combine with this Br and methyl will attack benzene ring. Plus HBr. So here ring with CH3 is called toluene or methyl benzene, and this is nothing but substrate in this form. So this is substrate and methyl bromide is reagent. This is second example. Name of this compound is methyl benzene or toluene. Yes, children. Now let me move to the other important concept, that is nucleophiles and electrophiles. See, out of homolysis, substrate and reagent, nucleophiles and electrophiles. You are going to have this homolysis, means the species formed in homolysis, that is free radicals. And nucleophiles and electrophiles in detail in class 12. How these free radicals are involved, nucleophiles and electrophiles are involved in substitution reactions. Now we are going to see only the concept and example. That much is there in your syllabus, particularly in this chapter. Right? Now let us see first nucleophiles. What are called nucleophiles? Right. Nucleo refers to nucleus. You know, nucleus contains subatomic particles called protons and neutrons. These are the subatomic particles which are lying inside the nucleus of any atom except hydrogen. Hydrogen is very simple, which contains only proton but not neutron. Other than hydrogen, if we move to atom of any element, it will have neutrons and protons in the nucleus. Of course, isotopes of hydrogen contain neutrons, but simplest atom of entire periodic table is the first element, hydrogen, which doesn't contain neutron, right? But its isotopes contain neutrons. Fine. That's a different thing. Now come to nucleophiles. Nucleo, as I told you, nucleo refers to nucleus which has positive charge. Since nucleus of a reacting species has positive charge, therefore other reacting species should have quite opposite charge, means negative charge. If negative charge is not there, lone pair of electrons can be there in its place. So here lone pair of electrons refers to non-bonding electrons, means those electrons which have not taken part in bond formation. So nucleophiles refers to the species which brings electron pair towards the reactive site of the other reactant. This is the concept. So nucleophiles refers to a species. Species means a particle or group of particles. In biology, species refers to a different thing. Okay, here species means fragment, piece, tukada, which carries electron pair. That electron pair should be non-bonding. So a species carrying lone pair of electrons and approaching reactive site of other species. Yes, species can be a reactant. Now let us see how is it represented. It is represented by Nu lone pair of electrons. This is representation of nucleophile. Right? So another point is nucleophile may contain negative charge or it may be a molecule with lone pair of electrons. Now, let us see examples for nucleophiles. Cn minus cyanide radical, which has negative charge. OH minus, which has negative charge. Now let us see molecules which do not have negative charge but lone pair of electrons. They have, like H2O. Remember, in whichever molecule of the compound, if oxygen is there, that will have two lone pair of electrons. Ether, ROR, oxygen is there. That oxygen has two lone pair of electrons. Alcohol, in that oxygen is there with lone pair of electrons. Next, another example, NS3, wherein nitrogen has lone pair of electrons. In any compound, if nitrogen is there, that will have lone pair of electrons. Like benzene ring with NH2, nitrogen is there. That is called aniline. Next, CH3 NH2. In that nitrogen is there. That will have lone pair of electrons. So that's about nucleophiles. We will move to electrophiles now. Right, children. So nucleophiles are nothing but the species which brings electron pair to the reacting site or the other reactant or other species. That is called nucleophiles. Now let us see electrophiles. What are called electrophiles? Electro refers to negative charge. Right? Electro refers to negative charge. And electrophile is represented by E minus or E lone pair of electrons. E with two dots. Okay. Nucleophile means a species which brings electron pair. Electrophile is quite opposite to that. That is, a species which takes away electron pair. A species taking away an electron pair is called electrophile. Electrophile. So to take away electrophile, taking away electron pair with it means it should have quite opposite charge. Then only it can attract that electron pair and it can take it with it. So electrophile should have positive charge. Nucleophile negative charge. So first point is electrophile should have positive charge. It is represented by E plus sign. So first point is electrophile should have positive charge or empty orbital because it is taking away electron pair with it, so it has to accommodate that electron pair in it. And example for this is CH3 plus. This is called methyl cation. See, it has positive charge, so it can take electron pair with it. And this electrophile can also be a molecule with empty orbital. Example BF3, boron trifluoride, wherein boron has empty orbital. To accommodate that electron pair in it, it can accommodate and carry with it. Okay. Next is aluminium chloride. This is another example, third example, wherein aluminium has empty orbital to accommodate electron pair in it. So that's about electrophiles. So electrophiles are nothing but a species taking away an electron pair is known as electrophile. And best example for this is methyl cation, which has positive charge, boron trifluoride, even though it doesn't have positive charge, since it has empty orbital, so it can accommodate electron pair to carry it with it. And third example is aluminium chloride, wherein aluminium has empty orbital. That's about the examples for electrophiles. Thank you, children.